The next example I want to do is question number 26 from the book, okay, where there is 5 cosine x over sine square x plus 3 sine x minus 4. So for this type of problem, again, so we want to do the partial fraction, but before that, if you change this by using the u substitution, then the problem will be easier. Okay, so what I want to do is set sine x equals to u, then cosine of x dx will be du, right? So the integral I can be written as I equals to 5 du over u square plus 3u minus 4. See that? So we're going to get the two factors there, so equals to 5 integral, you can add 1 over u plus 4 and then u minus 1 du. Does that make sense? Because when you add, you need 3, 4 and minus 1. When you multiply, you get negative 4. That is 4 times negative 1 is negative 4. Okay, now we do the partial fraction. So for the partial fraction, what I want to do is 1 over u plus 4 and then times u minus 1 is equals to, you can add a over u plus 4 plus b over u minus 1, right? So if you simplify the left side and right side, what do you get? You get u plus 4 parenthesis u minus 1, right? That will be cross multiplication a times u minus 1. That's not negative sign here, okay, and then plus b over u, b times u plus 4. That's what you get, right? Now the denominator thing, the left side and the right side will cancel out. So what is left is basically, you write on the left side 1 is equals to a times u minus 1 plus b times u plus 4. That's what you get, okay? So now we set u equals to 1. What do you get? You get 1 equals to, on the left side there is 1, that will be 0 if you set u equals to 1, plus b times 5, right? So you get b equals to 1/5. Similarly, set what is the next thing is u equals to negative 4, right? That's what you need to, that's what it makes 0, right? So you get 1 equals to a times negative 4 minus 1 is negative 5. So a will be negative 1/5. That's what the value of a and b. Hence, what do you get? Hence 1 over u plus 4 u minus 1. Okay, this is equals to negative 1/5 over u plus 4 and then plus 1/5, oops, 1/5, that is b, right, over u minus 1. Now let's add the integral sign there, integral, and then that will be du, and then du, right? What do you get? You get that is equals to negative 1/5. If you take the negative 1/5 out, what is left is 1. So the derivative of the denominator will be numerator. So it will be natural log of u plus 4 plus 1/5, and similar case natural log of u minus 1. But what is our plus c? What is our u though? U is sine x, right? So the final answer will be 1 over 5, negative 1 over 5 natural log of sine x plus 4 plus 1 over 5 natural log of sine x minus 1. But if you want to combine that, you can, because you can see that. So what is common? 1/5 is common, right? So you can write 1 over 5, and let me write down that positive term first, natural log of sine x minus 1, okay, and then minus natural log of sine x plus 4, right, and then plus c. So you can write 1 over 5. How do you combine that natural log? Because there is a natural log of something minus, so it will be divide, right? Natural log of sine x minus 1 over sine x plus 4, absolute value, and then plus c. That will be the final answer. Okay, so the next problem I want to do is question number 30. Yes, it is integral of e to the x, integral of e to the x dx over e to the 2x plus 1 and then e to the x minus 1. Okay, again we want to do u substitution and we'll come back later to that format. Okay, and then change that to u and then do the partial fraction, do the integral, and we'll plug in back e to the x for u. Okay guys, so let's say set e to the x equals to u, then e to the x dx will be du, right? What do you get? The integral, therefore integral I, therefore I is equals to what? Du over e to the x is u, so e to the x square, that means e to the x, if you do like this, will be, that will be u square, right? E to the 2 times x, so it will be u square plus 1 and then u minus 1 du, right? Now what we do next is we want to do the partial fraction, so 1 over u square plus 1 and then u minus 1 is equals to, this is quadratic, right? The first one is quadratic, so you can write ax plus b over u square plus 1 plus c over u minus 1. Now if you combine that, what do you get? You get ax plus b times u minus 1 plus c times u square plus 1, right? And divide by u square plus 1, u square plus 1 and then u minus 1. So you see that the denominator thing, that thing will cancel out, right? What is left is 1 equals to ax plus b times u minus 1 plus c times u square plus 1. Now we pick different values of x, that makes that 0. So let me pick u equals to 1, u equals to 1. If you do that, what do you get? On the left side you will get 1 and then that will be a times 1 plus b, but u 1 minus 1 will be 0, so that equals to 0 plus, that is 2c, right? Because 1 square is 1 plus 1 is 2, so 2c. So what is c then? This implies c equals to 1/2. We got c equals to 1/2 already, right? Now what do we need to put to make this 0? But there is no value of u that makes that 0, right? So what I want to do is I want to pick random values. Okay, so what I want to do is I want to do set, let me use different color for that, set u equals to 0. What do you get if you set u equals to 0? On the left side, on that you will get 1 equals to a times 0 plus b is b times negative 1, right? We get 0 minus 1 plus c is 1/2 times 0 square plus 1 is what? 0 square plus 1 is just 1, right? That's what you get, right? So you get 1, you subtract that, so it is 1/2, right? Subtract 1/2, you get subtract 1/2. 1/2 equals to negative b, therefore b equals to negative 1/2. That's what you get. So the next thing is I want to try different value, because there is no value that makes this and that 0 other than 1, right? See that 1 makes the whole thing 0 and no other values make any of the term 0. That's what we did is we tried u equals to, you can try any values, okay, no problem. So what I want to try next is I still have to find out the value of a. So what I want to try is, let's try u equals to negative 1. Let's try u equals to negative 1. What do you get? On the left side you get 1 equals to negative a, right? U equals to, I said, oh, by the way, this will be u, not x, okay? I'm sorry, that should be u. So let me override that. U, and there is u everywhere, u, okay? And then, yeah, so that will be negative a times negative 1 is negative a plus b. What is b? Negative 1/2, right? And then times u minus 1. U is negative 1, so that will be negative 1 minus 1 plus c is what? C is 1/2 times negative 1 square plus 1. I'm just plugging in that to find out the value of a, right? So what do you get? You get 1 is equals to negative a minus 1/2 times negative 2. You see that? and then plus 1/2 times negative 1 squared is 1 plus 1 is 2, right? So what do you get here then? You cancel that 2 and you cancel that 2 and then 2, right? Similarly, you can simplify that. What do you get? So you get basically 1 equals to, let me distribute this negative 2, so twice a plus 1 and then plus 1. You see that? So it will be 2. That will be 2, right? So subtract that 2, you get negative 1 equals to twice a. So basically a is equals to negative 1/2 as well. Okay, so we got a is negative 1/2, and then b is also negative 1/2, and c is positive 1/2. So what you can write here then? So you can write hence, let me use that color, hence 1 over u squared plus 1 and then u minus 1. This can be written as a is negative 1/2 u plus minus 1/2, minus 1/2, that is b, a and b, right? Divide by u squared plus 1, right? And then what? And then plus c is 1/2 over u minus 1. That's very good. Okay, so the next thing we do is we will integrate. So how do I integrate there? So let me write down that. So the right side is equals to, you can write negative 1/2 integral u over u squared plus 1 minus 1/2 integral 1 over u squared plus 1 plus 1/2 integral 1 over u minus 1 du everywhere. Okay, so what do you get here then? So what is the derivative of the denominator? That is 2u. So we did 2u on the top, right? So what I'm going to do is times 2 and then times 1/2. If I do that, then that can be written as log, because we know that integral of u over u prime equal, sorry, the other way. So u prime over u is equals to natural log of u. That's what the formula, because that's why we are trying to do if the derivative of the denominator is in the numerator, then the integral is natural log of the denominator. Okay, so you can write this as negative 1/4, and then this is natural log of u squared plus 1 minus 1/2. What is the integral of 1 over u squared? Do you remember this? Derivative of tangent inverse x is equal to what? 1 over 1 plus x squared, right? So integral of that will be tangent inverse. So there will be tangent inverse u, and then plus 1/2, that will be natural log of u minus 1. You see that? That's what it will be. Now plug in back the value of u. What do you get? Negative 1/4. U is e to the x, right? So u is e to the x here. So natural log of e to the 2x plus 1, that's the u squared, minus 1/2 tangent inverse e to the x plus 1/2 natural log of e to the x minus 1 plus c. That is the final answer. Okay guys, so that is all about the integration using the partial fraction. So far we learned many method to do the integration. So very first in Calc 1 you will learn the integration of by substitution method, and you learn the formula of integration involving logarithm, integration involving the exponential function. Then we learn integration we just learned the integration using the partial fraction. Also we did the integration using integration by parts, right, the product rule. And also we learned the trig substitution method for integration. So all those machineries that you learn will be used to do the complicated integral problem. Okay guys, so that's all the methods that you learn for the integration. In the next section you will learn how do we do because not all of the integral can be calculated manually. Okay, there are many functions which integral cannot be computed. There are many expressions which integral cannot be computed using the techniques that we learn. Okay, so in that case we will use integration by numerical method. Okay, finding, approximating the integral using the numerical methods. Okay, that's what we will learn in this section 8.6. all right guys.